Okay, hello everybody, and welcome to the San Diego Fine Woodworkers Association CNC SIG for the month of July in 2020. And we're glad to have you join us today. Howard Boehm is going to be presenting to us a couple of important topics. One is a method of inlay on the CNC machine using the V-bits. And it's called 3-2-1 Inlay. And then he's going to be talking about the laser setup that he has on his CNC and how he uses that. So I'm going to turn it over to you, Howard, and take it away.
Okay, let me get there real quick. So I'm going to share my screen here. Let me get rid of that. Okay, so everybody can hear. And I'm going to start, this will work in VCarve or Aspire. I'm going to bring in a piece of clip art and we're going to convert that, and then we're going to actually mill the male and the female side of the inlay. And I'll show you how to set it up and how it works. It's pretty quick and it's quite easy. So I've already set up a piece of wood. It's going to be 6 inches by 6 inches. And I'm setting my datum in the middle. I'm going to go grab a piece of clip art. The clip art, you can go, the best clip art I've found is what they call tribal art. And you go look on Google for tribal art images, and you're going to get all kinds of images like these. And these are almost 100% ready to work with. So once I bring in, like I say, this is a JPEG right here. Over here on the left-hand side, you got this tool that looks like a bird. And I think it is a bird, but it's for turning this into vectors. And when you click on that, it'll bring up a screen and it's going to show kind of the grayscale that it's thinking it wants. Being that this was so pure black and white, it's basically already ready to just accept. But if you had some other stuff that you wanted to make brighter or take out of that picture, you would adjust the corner fit, the noise, and you would adjust the color threshold up here on top. So I can preview by clicking preview, and you can see all the lines that it drew. And I'm going to say, let's apply that, and then we'll close. And then I can come up to my layers and I can shut off that bitmap. We don't need that anymore. So this looks pretty good, like it would work right from here, but I already know there's 1 or 2 spots that aren't going to work, but I'll show you how we detect those. So if we're going over to Carve, and I took these, and I got to get rid of this. Oh, hold on a second.
Was that a satellite view of your property there?
I'm not, yeah, it was. Okay, how do I get rid of this? I'll put it over.
What do you want to get rid of?
No, we're good. Okay, so I come over here and I want a VCarve. And let's say I hit VCarve. And being that this is going to be the female part of the VCarve, the start depth is always going to be 0. And I'm going to make this one real simple. I'm going to use 0.3 as the depth. And this 3-2-1 system, you'll see where this comes into play. I mean, this could have been 0.2, and then I would just do the math when we get over to the mill side, but I'll show you when we get there how we use this figure here.
And but just for clarity, in case anybody's wondering, the female part, of course, would be the base wood.
The base wood, the part you're carving into, not the part you're sticking into it. And I'm using a V-bit 60 degree. And then I don't have any areas here I need to clear out. Otherwise, I'd be using a clearance tool. We will use a clearance tool when we do the mill part, because we'll have a lot of wood to clear. So when I calculate Well, you got to pick vectors. I go hit calculate. And then this is what I wanted you to see. It tells us that there may be some issue. So if we go to the vector validator, now I got to move this thing again. Go to the vector validator and we search selective. You see where it put this little dot down here? I can come over here and zoom in. And the reason it did that, we got these extra two little boxes that we don't need. I'm just gonna, whoop, I gotta ungroup. I can just select the, come on. Ungroup objects. I select those two and delete it. And now it should probably, well, I got this one here. I just don't want, you got like a little straggly thing. You don't want it to be trying to fill that in. And then here's another one up in the corner. So out of that whole drawing, that's all I had to do to fix that. So now, I see one more little straggler down here. So now that drawing is fixed.
There's one more just above the bird's head, I believe.
Just above the bird, yep. Oh, two more.
Two. Oh, number of them.
Okay, so I'm going to come back. I'll group that back up. And while I'm at this stage, and I got them all selected, I'm going to move those to a layer. I'm going to call it a new layer. I'm going to call that the female vectors. Say okay.
Hey, Howard, I'm sorry. Can you show us where that vector validator was again?
I don't know how to get to it unless it's over here. It comes up automatically. I didn't do anything to bring it up. If it sees there's any overlapping boxes or any other things that it knows will cause a problem, it'll pop up automatically.
This is when you were calculating the toolpath?
Yes.
Okay.
Okay, so I saved that over there. I'm going to make that my active. Yeah, so there's nothing. Yeah, okay, so I got that. And I'm ready to go ahead, and I've got my flat depth set at 0.3. I'm going to calculate it. I'm going to preview it. And there we go. That's what it's going to cut out for the female part. Very simple. So I'm going to close that. I'm going to call this, I'm going to rename it. Female VCarve. Okay, so let's go back into our T. So we got that set up for the female. Now,
Howard,
yes.
I have a question. You did that preview, that was all done with the V bit, correct?
Correct.
And then I notice under the bird's neck and kind of its body is a very big area. Was the V bit used to kind of flatten out the bottom of that, or did you just go
Yes.
deep enough?
Nope, the V bit was used to flatten out the bottom.
Okay.
And if you had too much, you could use the like a 1/4 inch or an 1/8 inch end mill.
Uh-huh.
But this is pretty quick, so it might add an extra 30 seconds, 45 seconds to cut
Okay.
this out. This whole thing cuts out in about 90 seconds.
Okay, thanks.
So now that I did this, I'm going to add another new layer before I do anything else, and I'm going to call that the male vectors. Okay, so now I'm going to go here, and I'm going to right click, and I'm going to say copy to, did I not save that one? Okay, copy to new layer, male And I'm going to make that visible, and I'm going to make it active. Okay, so I can shut off the female. And now I have the male vectors. These are the male vectors here. If you use this just the way it is, it's not going to work because you're going to be flipping this board after you carve it 180 over into the other piece. So a critical part of your inlay is you got to take this right here and right now, and you want to flip it. And we're going to flip it on the horizontal. We're going to flip it about the job center, and we're not going to create a mirrored copy because we're just going to flip this one here. So if I hit flip horizontal, now we have the reverse, and that is what we needed. So now we can go, oh, and one other thing we got to do. We need, you can see where my mouse is, correct?
Yes.
All this area out here needs to be cleared off because when we carve this, this is all going to be proud of the wood. So we have to carve all this wood down, and we're going to use a, like a end mill to do that. So I've got to put a square, and I'm going to go slightly outside the box on all corners. And so when we, and I'll show you why we did that in a second. So now we're going to go over and we're going to select this and the bird. So we got the outer rim selected and the bird. This is going to get rid of all the wood all around when we do the clearing. So if we go to B, go ahead.
I would imagine if you had some really good wood that you didn't want to waste a lot of, or
right.
Stuff.
You would make a drawing very close and then cut it out with a bandsaw.
Yeah, you could probably ungroup it and then move the parts all up to one side or something, right?
Oh no, but you're going to miss out on some of the magic here, Doug.
Oh yeah.
Yeah, just watch
Yeah,
see what he does.
Right. Well, yeah, it's all one piece that you go in and cut off, right?
Yeah.
Yep.
Like I say, normally I would just I would go around this and then take it over to the bandsaw, but I don't want to have to move the camera over and have you watching me bandsaw it and all that. This way it'll just clear it out and it'll be done once we mill it.
Yeah, it's got the built-in holder kind of.
Yeah, so we got the V-bit, same V-bit. Now we got to set the start depth. And in this 3-2-1, the start depth on the mill is 2/3 of what the flat depth was on the female. And what was the flat depth on the female?
0.3.
0.3.
0.3. So 2/3 of that will be
100.
0.2. And the flat depth is 1/3 of that, which will be 0.1. And so we have our depths. We're using a 60-degree V-bit. We're using a 1/4 inch end mill, and I'm going to do it offset. So let's calculate. Once again, it helps if you select vectors.
Yeah.
Now we calculate. And as you can see from the patterns, it's going to get rid of all of this extra wood around the edge. So I'm going to come over here, reset the preview, and we're going to let me get the tool paths out of the way. So we're going to, here's the clearing path. And you notice that I went all the way past the edge, so I don't have to cut anything off. And then the BCarve portion, that's carving that. And of course, if you look at that, it's all proud, and that's what's going to slide down into that female part. So I'm going to take these, I'm going to rename this one male clearing. And I'm going to rename this one male recarve, BCarve. Okay. Now the hardest thing about all of this is to spell the word male and not spell it M-A-I-L, like I do all the time. So now we got our tool paths here, and close this. Now we got to save them. So I'm going to come over here. I've got my right post processor. By the way, when you do end up putting the laser on your machine, you got to make sure you use the correct post processor, because half the time I'll have the laser in there. If I forget that, I get really weird results. So, but anyhow, this is the right one here. I'm going to save the tool path. This will be our, actually, oh yeah, we're on the, I want the female. We're going to do the female VCarve. We're going to save the tool path. And I'm going to save it over here to female VCarve bird. Save. Okay, so we got that one. Then I'm going to come over here to male clearing. And we're going to do this. And we're going to have male clearing end mill, so I know what it is. Save. And then here's going to be the V bit. Save toolpath. And this is going to be the male VCarve. Yeah. And we'll know that one. Okay, so we got all those saved. So now we're going to come over here and go into our VCarve, our mock. I got to get this thing out of the way. Get over there. Okay, so we're over here. I'm going to load my G code. And we're going to do the female first. Female VCarve bird right there. I'm going to open. Okay, so you can switch over to my camera right at the moment.
Okay.
And let me see here. How do I get on that?
Howard, you may need to let go of screen share in order for it to maximize on your CNC.
Oh, okay. Oh yeah, here we go. Stop share. Okay, yeah, there we go. So I'm gonna, for those of you that haven't used the tape method, I'm gonna show you how I tape these down. I've already put tape on the back side. This is just plain old masking tape right here.
Howard, can you remind us what your CNC is?
Oh, it's a CNC Router Parts Desktop Pro.
And the cutting bed is?
24 by 36.
And you use a spindle on that? How much horsepower?
3 horsepower, I believe.
Okay, with a 1/4 inch or 1/2 inch shank?
1/2 inch shank. I'm using 1/4 inch today, but yeah, I can, some of the bits I use, this is the largest bit I use.
Holy mackerel. Oh, that's from your big red tray, isn't it? Can you show us your big red tray?
I can.
And tell us where you got all those end mills.
All those bits right there, I have a legacy ornamental mill, and I used all these on that, and I found out they would all work on the CNC just as well. So I ended up, I use them here for making all kinds of quick stuff. Like I can make a picture frame in about 2 minutes using big contoured bits.
Can you, did you sell your ornamental?
No, I still have it.
Still have it, okay.
Yeah, so
I'll
you
sell it real
make picture
cheap.
frames without
My
having
wife
to
wants
do
it
the
out of here.
corners.
Yeah,
Okay,
I know.
so I'm going to show you how we do the taping. Just add some tape down here.
For those who don't know, the shop changed its entire approach to hold down after watching a demo from Howard of how to do this hold down process. We completely changed over.
throw in a couple pins. Take my glue.
That's a nice touch, the pins for alignment.
Yeah, it makes it easier. Right?
Hey, Howard.
So that was super glue?
Yeah, with an accelerant.
That is going nowhere.
Howard.
Let me get the other one down.
This is actually kind of incredible. You're actually going to do both cuts as part of showing us this.
Yes. And I made it small enough that it's pretty quick.
Yeah.
So I'm guessing your spoil board has to be a pretty tight grain, like a solid. Is it a solid type of wood or?
It's MDF. You talking about my spoil board?
Yeah,
Yeah, it's MDF.
it's MDF. Okay.
Yep. Okay, so let's put this one down.
Howard's doing this so fluidly, you'd think that he was in production mode and had done this particular demo 100 times.
I like the little pegs for aligning it parallel to the x-axis.
Agreed.
I drilled those this morning.
That's a good idea.
Okay, so now,
So what's the dark wood?
dark wood is sapele, this is poplar.
Got it.
The female is going over here. I've already got an X marked in the center. So what I need to do is get this lined up. And a while back, I added a laser for lining this up. So I'm not always using a sharp point bit.
So regardless of the position of your head in the Z-axis, that red cross is
The red
a
cross
known
is here.
offset from 0, 0.
It's offset from the bit here.
Yep.
And on my mock, I have I reprogrammed the mock screen so that it has a button that says XY0. So now XY is zeroed, and I got to go back to the mock screen.
So it's like a little macro that just moves it based on your
Right.
offset.
Yeah, to compensate for the delta. Yeah.
Yep. Nice.
And then I got to
0 Z.
okay, auto 0.
I found out if your ground clip pops off while you're doing that, you put a nice little divot in your.
Yes, you do.
Yeah, or
Oh,
I think that's called part of the learning curve for everybody.
That is spring loaded.
Nice. Yeah. Yeah.
So you keep a finger. I mean, I don't care how long you do this. You're pretty close to that stop button on a lot of this stuff.
Yeah.
Okay, so now we've got everything zeroed out. So we're ready to cut the female part. I'm going to leave the dust shoe off just so you can see it. But normally I would have that on. Are you guys seeing this right now?
Yes.
Okay. I'm going to start.
Is your mouse on a magic carpet,
What?
Howard?
It's a whole new world, Travis.
Wow, it's a quiet one too.
Maybe that's why he can't hear us.
Yeah.
Or he's got good judgment and is ignoring me.
Oh, he's got a nice hanging air system there to blow stuff off.
Oh yeah, he's got a great setup on his shop. Guys, anybody remember his is CNC router parts, but didn't they just rebrand themselves recently? Anybody know what they're called now? I guess not.
See if I can find out.
Axiom?
Is the CNC really that quiet? I mean, I can hear him burst in the air every now and then, so it sounds like the CNC is silent.
Well, he does have a spindle. Let's ask him about that when he can hear us again.
Are you looking for the name Avid CNC?
Yes, Avid. That's the one. That's what it's called now. In case anybody was curious what CNC he did have, you wouldn't find it under the old brand name. They just rebranded themselves Avid CNC.
So he's got to have a noise canceling system.
Yeah.
And noise canceling systems work with repeating or
steady
sounds.
Yeah.
So that's why the air pops in every now and then, I think.
Exactly. Hey, Howard.
Yeah.
Can you tell us about two things? One, why on our end it's so quiet sounding? And then two, if you have a water-cooled spindle, how quiet is it when it normally operates?
It's not horribly loud.
We weren't hearing anything, so we suspect that that's just because of like built-in noise cancellation.
You weren't hearing anything, because you know why? He told me to turn my mic off on my phone because we were getting an echo.
Oh, I see. Okay.
Okay, so there's our email part.
That was impressively quick.
Yeah.
Yeah, no kidding.
Now the mill takes a little more time. So now we're going to unload. And I might as well, let me do one thing here.
Howard, how big was the clearing end mill? Were you going to do a quarter inch?
I didn't have a clearing end mill there, but I will on the mill.
Right, on the next one.
On the next one, it's quarter inch.
Quarter inch, okay.
Okay, so let me switch me back to my thing.
Okay.
Am I back on?
We're not there. He's not there yet. There we are.
There we go. Okay, so I'm going to share my screen again. Okay, so we got Mach. So I'm going to unload this one. So I'm closing the G code. I'm going to load the G code for the mill clearing. I'm going to open that. Okay. So now I'm going to go ahead and reset my, if you can switch back to the phone for a second.
Yep.
Hold on one sec.
So it looks like we see the placement of the part kind of in the right-hand side a little bit, but he's going to zero it and zero XY, which should then pop it to the left, right?
Right. So are you looking at my mock screen right at the moment?
Sure, yeah, it was, yep.
Okay, so
too.
I got the laser head right in the center. So see, this is the button I added, laser.
There you
It says
go.
laser, but I know what it means. XY0. When I hit that,
Yeah.
then it offsets it right back over top of dead center.
Yeah.
And Howard, Doug guessed that you just wrote a macro for that. Is that what it was?
I wrote a macro for that, yes.
Yeah, okay.
And then now I've just got to do
Oh,
my
that macro, was that all within Mach 3 or was that something else?
all in Mach 3.
Yeah,
Are you
Mach
gonna-
3 is really flexible.
Are you going to do the VCarve before you do the clearing?
No, I'm going to change. Oh, yeah, you're right. I would have thought of that in another second.
I was
Go
going to
ahead.
be quite amazed. I didn't know you could do that.
It's usually my wife out here saying, do you really want to do that?
Hey guys, while Howard is doing that, I just want to share with you what I just checked. Remember when Howard, in the early stages, selected all his vectors after he did the tracing and he found those areas where there were problems and it highlighted those? There was a little thing that popped up that helped him find those. That didn't ring a bell with me in VCarve, so I went and checked. Our version of that is it simply tells you how many unclosed vectors you have, and you have to go find them. So he's using Aspire, and it has a nice little utility for finding those things and pointing them out. In VCarve, you actually you're only told about them, and you have to go find them yourselves, and that's not nearly so helpful an experience to fix that up. So just so you know, what he did was from Aspire, and we can't really get that in our VCarve Pro.
Okay, we're ready to go back to the phone camera.
So why is it important to do
Actually, we're on the phone
clearing first?
You just do, because then it gets a lot of the other wood out of the way. It gets all the wood out of the way, and then the VCarve comes in and just cleans everything up the way it needs it.
Howard, we're on the phone camera. You just need to stop sharing on your screen if you want to see it.
Okay.
Doug, part of the answer is all the wood on the outside edges of it is gone at that point. So the V-bit only has to cut on one side as opposed to much more wood on all sides. It's easier on the end mill.
Okay. Right. So half of the
Exactly.
half the area is cleared away. Okay.
Exactly.
Cool. Thanks.
Okay, so here we go. This is going to take maybe 5 minutes, though.
Can you sing us a song?
Now we get to hear it.
Now you don't. Oh, there we go.
Definitely quieter than the shop CNCs.
Yeah. By
Those
the way,
routers are just
David,
so
just
loud.
because you've made the comment twice about the sound, we have ordered the new Z head so that it's actually on a Acme screw as opposed to a belt drive. That's not going to do much with the sound, but if that all goes well, the next step would be to put a spindle in as opposed to having trim routers for our spindles. And so it's sort of a two-step process here. Let everybody settle into one and then move on to the next.
Yeah.
We have 2 or 3
It'll be
people who've
great.
added them to Shape Bocos. I think the one who got us thinking about it most was probably Mark Stuke. And it's just remarkable how quiet it is. When he has been on the phone showing us things and running the CNC, it's almost embarrassing to have to be told that it is actually doing its job. Now, it's not doing deep cuts when it's that quiet, but it is just so much quieter to operate. And that just is really appealing.
I think the reason this sounds so quiet is because I think Zoom has some noise squelching built into it.
It does.
Is that going to be a water-cooled spindle?
The one that we're talking about would be water-cooled, yes.
Okay.
Oh, wow.
That's the one that Mark has, and he's sort of the one that's been guiding us on that. But, you know, we're not there yet.
So
Paul
what-
is one of the guys who is involved in the maintaining of a lot of those tools. And so, Paul, you'll know long before anybody makes any purchases.
Well, I mean, it's a great goal, I guess. Now that we're putting a big beefy motor on there, then more potential for damage, faster damage.
Yeah, the spindle itself wasn't that much more powerful. I mean, it's not like this 3 horsepower one that Howard has, but it was more powerful. And the more important thing was it was a whole lot quieter.
Yes.
Would you get a chiller then as well for the water loop?
Yeah, it would be the same sort of chiller that we use for the lasers.
Very classy.
Well, that'll be the next
sounds great.
stage. We're not there yet, but that's what the plan is to move towards.
And is that 110 volt
Yes, it is.
power requirement? So
It is. That's another reason why you're not getting all that much oomph out of it. But out of a 20 amp circuit, I believe we're going to follow closely, at least to get us started, what Mark has done. And there's one other person who put a spindle on theirs as well. I can't remember who it is offhand. Maybe somebody on the call does. But you know, learn from what our community has implemented, and hopefully just get a good result for the shop.
absolutely. Good.
So Doug, back to what we were talking about earlier, he showed me a piece he had done that had a bunch of little tiny 32nd inch pieces in it. And because it stayed on the backer board, they were all, everything was all lined up, and you know, it made a bunch of really nice little dots.
Yeah, the fine detail stuff. Yeah, for some reason I was thinking it was more like a puzzle, you know, that you kind of played the pieces in. But yeah, when it's like this, it's like a stamp, and you can really do some fine stuff.
One of our best examples of that has been done by David, who doesn't have a video camera but can show us screen. Maybe some point at the end of the meeting, you could show us pictures of what you had done, David, the turtle and the fish.
Yeah, I just shared it in the chat window.
Oh, okay, great. It's in the chat window there.
I think I saw them at one of the meetings. I think I spent most of my time at that table.
Yeah, pushing the limits of what you can do with fine detail there.
Yeah.
It really comes down to how sturdy your stock is that you're trying to do for the male side. If it's really strong wood, you could potentially do very fine detail, but once you got the fins sticking up, if they're really skinny, they're going to snap off.
That's a good segue into a question. Has anybody had any experience about using the hardwood that you want for the inlay on a sandwich of more sacrificial board instead of having to use a 3/4 inch thick of finer wood, solid wood, and take something off of more sacrificial board, because you're going to lose that anyhow when you during the process of resawing it.
I mean, when I resawed it, I was able to get it really close to the base piece, so I had a good 1/2 inch left over that I kept around and did more stuff with.
Okay.
Okay, we got the VCarve bit in now. I've got the software loaded. So now we're ready to start cutting the final piece here that's going to fit into there.
Haven't heard his compressor turning on.
Yeah, I think that's in his wife's garage. And I'm not kidding.
Okay.
Man, nothing is more credible than seeing it done before your very eyes. That's a gutsy move.
Yeah.
I've done hundreds of demos, and you know, if something's going to go wrong, that's when it's going to happen.
Absolutely. I've been looking forward to seeing this demo for a while. I
Yeah.
really want to give this a try.
I'd like to have his CNC is what I'd like.
It's quick.
Seriously.
I think this is the same model or type from the same family as what Perry Crutchfield has and what Mark Stuck has. Mark Stuck hasn't ever built his; it's in a garage, but it's a really sturdy machine that you end up having to choose a lot of the parts. Their old business model was tell us what controller you want, tell us what size bed you want, how sturdy you want the frame to be, what accessories do you want. You can't just go buy one. You have to buy the parts. But Howard,
Yeah.
when you assembled that baby, the documentation was really good, right?
Oh, yeah. Okay. So,
Now, what was the last moves that it did on the corners? What was the purpose of that?
I do not know. I have a feeling there was a couple stray pixels out there or something that I thought it had to get rid of.
Oh, it's not for indexing or anything else like that. Okay.
No.
It was doing it because when he'd made the design, he made the outside box larger than the wood stock, so the clearing bit would get all the corners. But because of VCarve bit also is following the same path, it thinks it's trying to carve little pockets that are nice and sharp in the corners.
In those
outside.
corners, yeah.
Okay, all right, thanks.
And for everybody that wonders how we get this cleaned up, got this little brush.
Ha.
Must be soft fibers.
Oh man, I remember horror stories of using a dental pick to get all the crap out.
That's a good idea right there.
As long as you don't break your fins in the nail
Right,
side.
that's what I was thinking, right?
So now, either this fits or it don't, but it will fit.
Did you blow out that female part? Or I don't think you. Just
The
yeah,
answer is yes now.
yeah. I was only thinking because it was left on while he was cutting and stuff,
Yeah.
so all kinds of stuff would have fallen in it.
So Howard, do you know offhand what the name of that brush bit is?
I don't offhand, but I will find it and I will post it. I've seen somebody using those, and it's always been an issue trying to clean those up, and that just seems to make it a whole lot easier.
They have things like that over at Marshall Industrial Hardware,
Okay,
Miramar.
let me see if I can get this zoomed in a little better. So if there's the male, there's the female, and if we're right, at some point when I slide this around, there it is.
Fabulous.
And
Yep.
I can throw some quick glue on there, and after I show the laser, I don't need this to be perfect or totally, so I'll cut that piece off and show you what it looks like. So let me just, if you want to see it finished.
Sure.
Absolutely.
Hey, Howard,
So
the camera drooped.
Camera's drooping.
Yeah. So is the 1/3, 2/3 rules gives you that separation so you don't have to cut or resaw through.
Your good stuff.
You just
Yeah.
resaw through that negative space, if you will. between items? Okay.
And I think I've seen mentioned somewhere that whatever you do on the female, as long as the two measurements on the male part add up to 2/3, it'll still work. So if you wanted less space or more space, you could probably get it.
Got it.
Yeah, interestingly, the 1/3, 2/3 doesn't really matter. You could get whatever space you want underneath of the male part into the pocket, and then as well as whatever distance you want between the inlay and the base, so before resawing.
Yeah.
It just so happens that those numbers work out conveniently.
But
Oh.
David, it's such great branding.
Very good.
Well, for instance, if you want to only have a pocket, like the distance between the male and the pocket bottom as 0.05, but you want to have a lot of mating surface so that glues well, you could have it be, 1/5, 4/5 or something, and it would still work out nicely.
Very good. Thank you.
Yeah, basically it works out such that the distance between the male side and the pocket bottom is the female flat depth minus the male start depth.
I'm sure I'll
Control that
remember
however you
that
want.
in 6 months.
Okay. So let me just take this bit out, and then we'll talk a little bit about the laser.
Hey, Howard,
Yes.
do you suppose at some point, if you wouldn't mind, just giving us a 360 of your shop and talking about what you have, so just so we can see how somebody has set up one situation?
There is my CNC machine. And there's the stand I built for the CNC machine.
Got it?
And that drawer you've seen with all the bits, that's down here.
Right, okay.
And then just the miscellaneous junk up there. Behind me is the drill press.
Okay.
I've got my 15-inch planer, and when I use this, I move it out to the driveway. There's the bandsaw. And I got all these on wheels, so that pulls out. Toolbox. And
Hey, Howard, it
yeah,
was commented that we didn't hear the compressor kick in. Is the compressor in that room?
yes,
Oh, it is?
it is.
Oh, okay. I thought you moved it to your wife's garage.
Oh, wait a minute. Let me turn the sound on here. Can you hear me now?
Yeah, we
Yeah.
can hear you.
Okay.
The
I didn't know
compressor
if you're
was
hearing me
not
from
put
the
into a
phone.
different room?
If you're turning the sound on your phone, you're going to start getting echoes.
Okay,
Unless you're going to another room, like you say.
then we're good. As long as you can hear me.
Yeah.
So here's my, I got a Delta Unisaw, 52-inch or whatever, 57-inch. I've got a router table built into the far end. Over on this side, I've got my belt sander, my spindle sander, which slides out. Over here, I have my miter saw station.
Fabulous.
Yeah.
And then over here, I know this looks insane, but these are all the glass case to all the different tools. And I'll show you why I have that set up that way. I just replaced my shop vac. And not shop vac, guess what?
Howard, you've frozen. There we go. Okay, so it is in the other garage. Okay.
And this thing is like literally double the amount of draw of my old machine. You know, here's my different tool cabinets. You know you're a tool for when that's your nail gun cabinet. You know, can't have one. And glue, sandpaper.
Howard, how many batteries do you have?
A couple. So that's the shop.
That's great. Thank you.
Yep, nice.
Okay, so now let me get this set up. Okay. So when we want to go to laser,
Howard, could you tell us about the laser? It's a diode, and what's the power?
it's 6 watt, a true 6 watt.
Not fake 6 watt input, but real 6 watt power burn.
6 watt constant power across the whole spectrum.
Got it.
And this is the laser.
Just so people understand, when we talk about diode lasers in our tours, we're talking about words like 15 and 20 watt. But the truth of the matter is, I can't remember exactly. I think it's less than 1/3 that number. Like a 15 watt is actually more like 4.2 watts. So compared to even the 20 watt, this thing is more powerful, probably. I'm not sure about the 20, I guess, but this is a really great one.
To put this on, they have a magnetic setup. I take off this dust cover and I just go right here. Now my laser's installed and I'm ready to go lasering.
You don't have to plug it in?
No. See right back behind us?
Oh, okay.
There's all your wiring and connections.
Yeah,
This
okay.
side. And when you put it up there, you're all
Smart.
set up.
Smart.
That's pretty slick.
That was probably one of the main reasons I bought it, because I didn't want to leave a laser on there so it would get all dusty and dirty and so on. So I ended up doing that, and that seems to work very fine for me. So what I wanted to show you, I was going to take, where did I put my Here I was playing around, like here's one of those birds. I did that with fill, and then there was the outline. I did that with an outline. The top one took 3 minutes, the bottom one took 22 minutes. And then I was just playing around with different amounts of fill. And then
Howard, do you use the laser feature in the new VCarve software or Aspire, or are you using Lightburn?
I can't use Lightburn because I can't control the laser directly from Lightburn because it's going through my controller. So that's out of the question. And what was the other question?
There's a new feature in VCarve.
Oh, the new feature in VCarve, the good news is it'll work for anybody that has a VCarve, that has a Shipoko or any of those machines. They've got it working in those. Right now, I've been working with them with Vectrix, and we have yet to get mine to do photos, but I rewrote a post-processor, and so I can do lines and fill all day long. And eventually we'll have it working on here. But I had the module about 2 months ago, and I just actually re-downloaded the new one to see if they maybe made any more changes. But they only got it working for about 6 or 7 of the CNC
controllers, right?
What?
Isn't it based on the controller?
Yes, yeah, it's based on how you're set up in the controller.
Yeah.
And right now, they just haven't figured out how to do it on this one.
Got it. Okay.
And there's about 3 or 4 of us that have these that we're trying to work that out, but we haven't got there yet.
So what were you using before either? I mean, you didn't have Lightburn and you didn't have the feature in Aspire. So what were you doing to control the laser before?
Just a plain old Aspire. I was using the engraving tool.
Ah, okay, got it. Okay.
So if let me get back out of here.
Can you show your targeting laser real quick? And
Yeah.
how that's mounted and such?
Oh yeah. Let me take the camera off here. So here's how hard it was for the laser for centering. I got this bracket. There's the laser right there. This wire comes up here and it goes to a battery pack.
Oh,
And the pack has a switch on it.
Yep.
So you don't even have to wire it into your system. That took about maybe 30 minutes to set up.
God, that is so simple.
Do you have a brand? Do you know the brand name on that?
Actually, I have a video out there.
Okay.
If you look crosshair laser, I think it's the #1 video. I have all the links to all the different parts, how to do it, how to do your measurements and everything. Because it's very easy to do the measurements. You put in a V-bit, mark a center point, and then you zero it out on your computer. Then you bring your laser over to that exact point and look at what the figures are in Mach 3 or whatever software you're using. And that's going to be your offset. And then you program that in to whatever you use to program, your laser. I mean, your
Right.
Very slick, very slick.
So let me pull out. I got that same thing we just did. Let me go over here to. I'm going to share my screen again. Okay. So we want to go over to Vectrix. Close this out.
Okay, Howard, let you know we should be wrapping up relatively soon.
Okay, I'll just give you one quick little look at this, and then we'll call it a day. Actually, let me just go over here then to Mach 3. On Mach 3, load, close G code. Oh no, I got to do a different one. Okay. Well, if we got to wrap it up, if you wanted to see one laser in action, I can do that.
Can we take a quick vote?
Sure, everybody, show of hands. Stick around for the whole thing.
Sure.
You see the laser?
Okay,
Sure.
go
Okay.
for it, Howard.
Okay, so let me open up Mach 3, Mach laser. Load G code. I think I probably have one here. Laser cut. Laser cut that one. Okay. And, okay, yeah.
You have to stop sharing your screen so we can see the, well,
Yeah.
that got it, I think.
Okay, yeah, let me do that. Okay, so what I'm doing is, it's got to be 40 millimeters, and that's right there. I'll go just a little bit lower. Okay. And just for expediency,
Everybody put on your laser glasses.
for expediency, I am going to X, Y, Z that. That don't look right.
Sam Takahashi was on a meeting last night, the laser SIG, and somehow the idea of mounting a laser on a CNC came up. And Sam said that we should all be sure to touch off on our laser as well. Is that a true statement, Howard?
No, you don't. I'm referencing all home here. Okay, now we're good. Okay.
What is your focal length?
40 millimeters.
Yeah.
No, 60 millimeters.
Okay.
Okay, so I got that all centered. 0, 0, 0. Generate toolpath. Now it looks right. Okay. So I'm going to turn my laser on.
Ed, we should put on ear protection too, right?
Yes.
Okay.
Look away. Divert your eyes.
There we go. Okay. Well, you know what? Something ain't right here. I think, you know, I'll try it. If it works, it works. If it don't, it don't. Yeah, that ain't right.
Even if it doesn't work, it's quite a nice setup. I'm
No
very
kidding.
envious.
Yeah.
No, I got 3 lights instead of 2. I need to reset it. That's only happened like twice, but I know it ain't gonna do the right thing.
Howard, don't sweat it.
I don't think, yeah, I think we're done.
Hey, Howard, just out of curiosity, have you been doing anything? I mean, we've seen your 321 and your laser in the past, but have you been tinkering with something new? Is there a new technique you've been working on? I'm only asking because, you know, Ed may be able to ask you a favor in the future of something you've just started doing that was just kind of cool. Anything like that?
A technique for
CNC.
Well, on the inlays, where did I put it? Hold on a second. Oh, here we go.
And before we forget it too, Howard, we want to get the PDF, the location of the PDF for the
Oh, yeah.
321
Yeah.
Inlay.
Yeah, let me pull that up real quick. Oh,
Hey, Paul, what is it you put into the chat? What is that YouTube video?
That would be Howard Beam's crosshair video.
Yeah, that's Howard's crosshair.
Ah, okay, great.
CNC complete how-to for under $40.
Oh, nice. Okay.
I'm going to do that.
First person to figure out how to implement a macro in carbide motion, let us know.
there you
Probably
go.
just loading a file that you keep around and running it.
Okay, I thought I had it right here. Huh.
Well, if you can email me the link to it, I'll put that
Yeah,
into the,
I'll email you the link. I can't find it.
that's fine.
But one of the things I tried, I figured, okay, if this 321 works with a VCarve bit, I was watching a couple of videos and it looked like the guy was using a tapered bulb, bit.
Yep.
And so I made this little sign. Oh.
Oh.
And all the dark wood is one piece and the inlay is the lighter piece that
wow.
went down over top of that. And that worked quite well. And so I was going to make I was trying to get ready for the class, but I wanted to try it with just some off-ball, like a round cove bit and see if it would work with that,
yeah.
Adjust accordingly. But I haven't got around to that. But once you get that chart, it works pretty right out of the box. I mean, you can sit down, follow the directions, and you're going to have an inlay, and the inlay is going to work first time and every time. When I first started trying to do the inlays, I tried playing around with all those figures and everything else, and every time it was screwed up one way or the other. And this has worked so religiously well that I just, use it. It's important to use the right type of wood. I tried to make this one, and this has some really fine detail, which you can't see on the screen. But there was like little micro dots, and it actually filled those in, and those actually inlaid. But I was using oak for the inlay wood, and you never use the mill as oak, because oak is stringy, and when it cuts it, it'll tear it, and so you don't get good fine joints in oak.
Got it.
Other
Super
than that,
useful, Howard.
that's about all I'm doing right now.
That's great.
Okay, I'm going to take this opportunity then to close out the video. Thank you very much, Howard. Wonderful presentation. It's been very enlightening, and we will be, of course, putting this up on the website. So I'm going to stop the recording now, and then we can chat a little bit more if you want to.